Good morning, students. I hope you all are well. To learn mathematics, it is required to work hard, to pay concentration, and to do practice and practice and practice. There is no shortcut to learn mathematics. You have to revise the basic concepts again and again. These days, we are doing linear algebra and we are revising the basic things that will be used in linear algebra. So, let us continue. We have done algebraic structure under this set binary composition. It is divided into two parts, internal and external composition. Now, let V be a non-empty set. Let F be a field. Now, F is a field. You remember, if this is a field, then it is algebraic structure consists of two binary composition addition and multiplication. That means write like this. Field is an algebraic structure and this includes this. So here F is non-empty set, must be non-empty. Second, plus this is from F cross F to F and multiplication. This is also from F cross F and both are internal composition. This plus, that is addition composition, this is multiplication. Here F is commutative with respect to addition. Again I repeat, F is commutative group with respect to addition. Second, F is also commutative group with respect to multiplication. Commutative group with respect to addition, commutative group with respect to multiplication. And third, the interconnection of these two operations, that is distributive property holds. That means for all A.C. Additive group, but it is commutative. Multiplicative with respect to group with respect to multiplication, and this distributive property. So this has 5 properties, this also has 5 properties and 1 distributive property. So 5 plus 5 plus 1 means 11 properties. So whenever you write F be a field, it is a single statement, F be a field. So whenever you write F be a field, as soon as in your mind you think there is a non-empty set F, there are 2 binary compositions. One is additive, second is multiplicative. Then F is an abelian group, or you can say commutative group. J is also commutative group, abelian group, and third, that is distributive property holds. Instead of commutative group, you can write abelian group. How many properties? 11 properties. 5 plus 5 plus 1. So as soon as you write let F be a field, it includes all the things. This is very important. Okay. A non-empty set V equipped with the following two binary composition, a non-empty set V with the following 2 binary composition is known as a vector space over the field F if it satisfies the following properties. Listen, a non-empty set V, it must be a non-empty. How many operations are involved here? Two. Two binary compositions. Two binary operations is known as a vector space. Who known as a vector space? The set V. Which type of set V? Non-empty. And it is equipped with two binary operations, and it is known as vector space. The name of the set, that is vector space, over the field F. Be careful. Here it is written over the field F. Means this has 11 properties that I have just explained. So your F is a field, then immediately in your mind you must have the set F equipped with the two binary operations denoted by plus addition and dot, that is multiplication, satisfying the 11 properties. So here it is, a non-empty set V equipped with the following two binary composition is known as a vector space over the field F if it satisfies the following properties. Now the first operation, plus, but remember F is a field. Therefore, is an algebraic structure satisfying some properties. This is a field, means this is an algebraic structure satisfying 11 properties. Now here the plus sign is used. Remember, this plus sign is different from this one. This equipped with the two binary compositions, this also has two binary composition. So if this is denoted by this sign, that is plus the ordinary addition, then I have to change the symbol here. So either you can change the color of this particular symbol, but it is very difficult while we write something. So it is better to change this. I put a circle over it. This is the first binary composition defined in V. It is from V cross V to V. This is internal composition. Second one is dot. This is F cross V to V. external composition. Now remember, it was explained yesterday in the fourth video what is internal composition and what is external composition. So if you have any doubt between these two, you just revise that particular video. Again I repeat, non-empty set V along with two binary composition denoted by this symbol. This is the internal composition. It is from V cross V to V. That means this is the set of ordered pairs. So this is the particular one. Result means the image of this member will be this. Here it is F cross V. One element is from F, means from this one, and other element is from this. But the answer is in V. Listen, F is a field. I will say here the elements of F are called scalars. The elements of F are called scalars. The elements of F are called numbers. The elements of F are numbers, means maybe positive, negative, 0. Okay, if F is a field, and if I say F is a field of real numbers, if F equals R, set of real numbers, then this is a field of real numbers. That means you have all types of numbers except the complex and that one particular part of it. So here it is. If F equals to R, that means on number line we have the numbers from minus infinity to plus infinity. All numbers we have, natural, integers, rational, irrational, 0 also. All that we have. So it is V cross V to V. It is F cross V to V. Here you see this plus means addition of two elements of F. Which type of elements? The set F has numbers. Means this is sum of two numbers, means sum of two scalars must be a scalar. Second one, multiplication, that is ordinary multiplication. So multiplication of two elements means multiplication of two scalars is again a scalar. So this plus is the addition symbol, this dot multiplication symbol. Which type of elements? F has numbers, that is scalar. So it is sum of two scalars and multiplication of two scalars. Here it is different. Here one number is from F and other number is from V. I have already explained you. One number is from F, suppose I say it is 2. Other number is from this one, suppose I say this is a matrix 2, minus 1, 3, 4, for example. Here one number is from this 2, minus 1, 3, 4. This is the way. What is V here? Set of matrices. What is F here? Set of real numbers. So plus means addition of these two. If we add these two matrices of order 2 by 2, the answer is again a matrix. Here you see, here the composition is plus. Here the composition is multiplication. But here multiplication is different from the multiplication here. Here this dot is between two members of F. Here this symbol is between two members. One is from this and other is from this one. Here this is kept between two numbers like 2 and 1 by 3. So if I multiply 2 and 1 by 3, the answer is 2 by 3, and 2 by 3 is again a real number. Here it is defined. Plus is internal composition, dot is internal composition. Here plus is internal, so both the members will be from the same set. The nature of the elements will be identical. एक जैसा. यहाँ different है. One element is from this set, other element is from this set. This includes numbers, scalars. This includes matrices. So the pair is formed with the help of number and matrix. And here the pair is formed with the help of matrices. So here multiplication of this one, that means it is known as scalar multiplication. Here I have used the word multiplication, means ordinary. Here it is scalar multiplication. Okay. So when 2 is multiplied by the matrix, you know that how to multiply a matrix by a number. We multiply all entries by this particular number. So answer is again a matrix. That means this operation is closed. This operation is also closed. So be careful. A non-empty set V equipped with the following two binary composition. One is addition, other is multiplication, but is scalar multiplication, is known as a vector space over the field F. Over the field F. इसके बिना काम नहीं चलेगा. If I simply say let V be a vector space, then it is understood there exists a field. Otherwise we cannot define this one. So if I say let F be a field, that means you have all the things. So if I say let V be a vector space, it is understood that the field is given. So the complete sentence is let V be a field, let V be a vector space over the field, whatever it is, over the field F. F may be real numbers, F may be rational numbers, F may be complex numbers. But whatever you consider the set, it must be a field. Okay? Now come to the point. Addition, scalar multiplication. Elements of F are called scalars, and here the elements of V are called vectors. I repeat, the elements of V are called vectors. The elements of F, that is field, are called scalars. Remember, scalars means numbers. Scalars means numbers. Again I am saying you, scalars means numbers. If it is set of real numbers, then from minus infinity to plus infinity on the number line. Again I repeat, don't get confusion with the word vector. That you have learnt in vector algebra and physics also. Here the elements of this set V are known as vectors. Here vectors means the elements of V. Here vector is not, I am saying here vector is not the vector quantity that is defined in vector algebra and we have learnt in physics as well as in mathematics. If I say V is a set of matrices of order 2 by 2, it means the elements of V are matrices. It means the matrices are vectors here. Again I repeat, here vector does not mean the vector quantity. यहाँ इसका मतलब सदिश राशि नहीं है, यहाँ वेक्टर का मतलब जो है वो इस सेट के एलिमेंट्स हैं, हमने उन एलिमेंट्स का नाम वेक्टर दिया है. So if V is the set of matrices, that means matrices are treated as vectors. Again I am telling you here vector is not considered as a vector quantity, may or may not be. Okay, so elements of V are called vectors and elements of F are called scalars. Okay. I hope you have understood. A non-empty set V along with these two binary composition, one is addition, other is scalar multiplication. So here addition means addition of elements of V, and what is the name of the element of V? That is vector. And here vector is not the vector quantity that is defined in vector algebra. If V has the elements in the form of matrices, then our vector element is the matrix. Here matrix is treated as the vector and that is the element of set V. Okay, so here it is internal composition. This is addition. So we will say it is addition of vectors. Here we say scalar multiplication. Scalar multiplication means one scalar and one vector. Again I am telling you, one scalar means one number and one vector. So if we use this operation, the answer is again in V. So this composition is closed. This composition is also closed. Now if we have the composition, then definitely the composition will satisfy some properties like this. F is a field, means this includes two binary composition. This satisfies 5 properties. This also satisfies 5 properties. With respect to this, F is an abelian group. With respect to this, the F is again abelian group, and one more connection, that is distributive property. So be careful. This plus sign is different from this one. Here plus is addition of two numbers. Here plus means addition of two vectors. Here into means multiplication of two numbers, and here into means multiplication of number and vector. That is called scalar multiplication. Now we discuss the properties. Addition. This is the symbol. For all closure property. The first composition, I am writing the properties of this one. The first one is closure property. Generally it is not written, but I write it. Since it is binary composition, so this holds. So that means this is the closure property. You consider any two members of this one. Since this is the addition, so addition of two vectors is again a vector. Okay? A2. Associativity, Sahacharita. There exists zero belongs to V. What is the name of the element of V? Elements in V are called vectors. Here vector does not represent the vector quantity given vector algebra or in physics. Elements in V are called vectors. So here alpha is a vector, beta is a vector. If it is vector quantity, then I will use this symbol. This is a vector quantity. I am not using this one. I am not interested in vector quantity. I am interested in that set whose elements are known as vectors. I am interested in that set whose elements are called scalars or numbers. So I have two sets. One is V, other is F, but F is defined exactly. There is no doubt in the definition of F. That is, F is the field. The set V, we are defining. What is that? V is a non-empty set and its elements are called vectors along with two binary compositions. One is known as addition other is known as scalar multiplication. One operation is internal, that is addition. Other operation is external, that is scalar multiplications. Okay, so look at this. This is 0, 0. It looks 0. But what is the name of the element of V? That is vector. So here it is 0 vector. Or I say null vector. Or I say 0 element. There exists 0 element such that for all alpha belongs to V, this property holds. That means identity element exists in V. If V is the set of matrices of order 2 by 2, alpha of order 2 by 2 with real entries, that means such that belongs to this set of matrices of order 2 by 2. So alpha is one of them. So I write alpha as, for example, alpha is 1, 2, minus 1, 3. Here the symbol is plus. Remember, it looks 0, but it is not 0. It is not 0. It looks 0, but it is not 0. That's why I have written here. This is the 0 vector, null vector, 0 element. किसका एलिमेंट है? V का एलिमेंट है. V के एलिमेंट को क्या बोलते हैं? वेक्टर बोलते हैं. यहां V कौन है? सेट ऑफ मैट्रिसेस. इसके मेंबर्स कैसे होंगे? मैट्रिक्स की फॉर्म में. इसलिए यहां वेक्टर कौन कहलाएगा? मैट्रिक्स कहलाएगा. इसलिए यहां जो 0 होगा वो 0 मैट्रिक्स है और वो होगा नल मैट्रिक्स. सो इफ अल्फा इज दिस, then there exists a null matrix of order this belongs to V, such that you know that this is a 1, 2, minus 1, 3 plus. If you find the answer, you will find this is a answer is this is the operation. Look at carefully. This is not 0. It looks 0. दिमाग क्लियर होना चाहिए कि आप क्या लिख रहे हो. That's why mathematics requires 100% commutation. So here the set V, and this element is the member of V, so this is not 0, this is the 0 vector, because the name of the element of V is known as vector. And here V is the set of matrices of order 2 by 2. So 0 means the 0 matrix of order 2 by 2. So there exists this matrix which is added to any other matrix of order 2 by 2. The answer is the matrix again. Here you can see this matrix is added to this in both way, left or right. The answer is the matrix again. You can see this. This is the property. This you have done in abstract algebra. So I hope you have understood, but you remember the symbol plus with circle. This symbol is used between two vectors. So it must be a vector, it must be a vector, and here vector is in the form of matrix. So this is a matrix and this is also a matrix. That's why this symbol is used here. So here closed property, associativity, identity element exist. Now the fourth one, that is E4. For every alpha belongs to V, there exists beta belongs to V such that for every alpha belongs to V, there exists beta belongs to V such that this property holds. It means inverse of every member of V, inverse of every member of V exists, and here beta is called the inverse of alpha. This is called additive inverse. You know how to write the additive inverse. If I say alpha is 1, 2, minus 1, 3, then you know how to find beta. When you add these two matrices, you will find that is denoted by this 1 minus 1, then minus 1 plus 1, and 2 plus 2 minus 2. Okay, then this and this, you will find this one. And it is with respect to every matrix. So we find this. Okay, so inverse exists. This is the fourth one, and I write the fifth property. E5. That is, for all alpha beta belongs to V implies addition is commutative. Here addition is commutative. Instead of addition is commutative, I can say vector addition is commutative, because we are adding two vectors. And again I am telling you, a vector doesn't mean the vector quantity that we have learnt in vector algebra or in physics. Again and again I am telling you. So this is commutative. That means this operation plus it is closed. Closed. Second, associative. Third, existence of identity. Fourth, commutative. How many properties? 5 properties. 1, 2, 3, 4, 5. And you remember, you have done. If a binary composition which is on the given non-empty set satisfies all these properties, then that given non-empty set is known as abelian group. Therefore, here V with this is an abelian group. Okay, so today is enough. You revise whatever I taught. We have discussed a non-empty set V with two binary compositions. One is internal, other is external. With respect to internal binary composition, the set V is an abelian group. Tomorrow we will discuss the properties satisfied by the external composition, that is scalar multiplication. Okay, so thank you very much. God bless you.